Hello students, welcome you all. So today I am going to continue the topic which have already discussed in the last class, that is matrix and the different types of matrix. Today we are going to discuss about the algebraic operations in a matrix. Algebra of matrices. Algebra of matrices, which is also known as the operations in matrices. Okay, so I hope all gone through the last discussed topic, that is matrix, what is matrix and different types of matrix. See, because the concept that we taught in the last session is very important to understand the current class. If you want to know the various operations in matrix, first of all you have to know what is matrix and different types of matrix. Okay, and regarding here, one thing is important that we have already discussed, that matrix, okay, how matrix is constructed with numbers, with symbols. Clear? Number means integers, maybe it positive or negative integers. Clear? And next thing is the order of the matrix. Okay, order means the number of row and column upon which the matrix is constructed. Okay, as I suggest, that is A, the element I, J, I for row, J for column. Okay, so the matrix is the matrix is recognized by its order. The order is very important. Okay students, so when we are going through the operations in matrix, the order is the most important factor here. Okay, if we don't know what is order, okay, how to know what is the order of the matrix, we cannot do the operations. So that's why please go through the previous class. Clear? I hope you all clear about order of matrix. Okay, so now I am again just a blink of the previous class, that is what is order. As we say, if 2, 3, 4, 5 in this matrix, what is the order of this matrix? As I said, the order is the number of rows, the number of row into number of column, number of row into number of column. So students, how many rows are there? Row 1, row 2, here column 1 and column 2. Clear? So here we have 2 row and 2 column. So this is a matrix of 2 into 2 order, 2 into 2 order. Okay, then again if I say 1, 3, 6, 2, 4, 0, okay, then what is the order of this matrix? The order is, we have row 1, row 2, row 3 and column 1, column 2. So we have 3 rows and 2 columns. Okay students, so please make it a point that is very important to make the algebra of matrices. Okay, so now we gone through the algebra of matrices. Okay, so see, in the algebra of matrices we have two operations or two algebraic operations are done with the matrix. Okay, those are number 1 addition, okay, that we call addition of matrices. Okay, what is matrix and matrices, students? Don't get confused. Matrix singular, matrices plural form. Okay, so addition of matrix. Number 2, subtraction of matrices, okay, and the multiplication of matrices. Okay, so today we are going to discuss about these 3 operations. Okay, so first we discuss about addition of matrices. Okay, as we know simply what is addition? Addition of matrices means when we are going to add 2 matrix. When we going to add 2 matrix. Okay, so see 2. Okay, students, addition of matrices means when we obtain a new matrix by adding 2 or more matrix. The matrix that we obtain, clear, or when we obtain a new matrix by adding 2 or more matrix. Okay, say for example matrix A and B is given. Matrix A and B is given. Okay, so if you want to add, then simply we do what? Adding A plus B. A is the name of a matrix and B is the name of another matrix. As we know, the matrix, the full matrix is denoted by a name. And what is the name? The name denoted by a capital letter A to Z. Clear? So here A, B means A is a given matrix and B is also a given matrix. So if you want to add 2 matrix, then we have to A plus B. There we derive a new matrix. Maybe we call it as a C. C is the new matrix which is derived, which arrived, okay, by adding 2 matrix. We can do it with 2 or more matrices. Okay, clear, students? So see, while we are going for addition, if we want to add 2 matrix, as in other algebraic operation, while we are going for addition, we can add any 2 numbers. Yes, is not it? We can add any 2 numbers without any restriction, without any condition. Clear? But here in the addition of matrices, there is a condition. There is an important condition. If that condition is satisfied, then only we can go for adding 2 matrices. Okay, what is the condition? See, it's very simple. The condition is 2 matrices can be added. 2 matrices can be added if both are of same order. Both are of same order. Okay, same order means both must have same number of rows and same number of column. Okay, so there is a condition for addition. What is the condition? The condition is that we can add 2 matrices if both have of same order. Both have of same order. Same order means both have equal number of rows and columns. Equal number of rows and columns. Clear? If we have two matrices, both are of same order, then only we can add the two matrices. Otherwise, we cannot go for adding the two matrices. Okay? Clear, students? So here one thing is clear, that we can add equivalent matrices. Equivalent matrices can only be added with each other. Okay? Equivalent matrices can only be added with each other. Okay? There is one condition, that both must be equivalent. If both are equivalent, okay, what is equivalent? When both the matrices are of same order. If both are of same order, that is equivalent matrix, and we can add only a equivalent matrix with each other. Okay? Clear, students? So same order means if we have a given matrix A, which is of 2, 3, 4, 0, minus 1, 3. Okay? This is a matrix of what order? Here the order is, we have 2 row, 2 into 3 column, 1, 2, 3. So 2 into 3, this is order of 2 into 3. And B is given, let B is given 0, 1, 0, 2, 3, 6. Okay? This is also a matrix with order 2 into 3. Okay? So these two matrices can be added because the condition is satisfied that both matrices are of same order, that is 2 into 3, 2 into 3. Okay? So how can we add? What is the procedure? It is very simple. If we ask to find A plus B, if you ask to find A plus B, that is very simple. Adding the corresponding element. Adding the corresponding elements of two matrices. Corresponding element means, as we know, students, the position. Here 2 is A11. A is 2, 11, row 1, column 1. Row 1, column 1, and 3 is row 1, column 2, and minus 1 is row 1, column 3, and 4 is row 2, column 1, 0 is row 2, column 2, and 3 is row 2, column 3. Yes or no? Clear? So here also same. A11, 0, A11, 1, A12, 0, A13, 2, A21, 3, A22, 6, A23. Okay? So it is very simple. Adding the corresponding elements. Corresponding means A11. Clear? The corresponding element of A11 is A11. The corresponding element of A12, A12. Corresponding element of A13, A13. Corresponding element of A21, A21. Corresponding element of A22, A22. Corresponding element of A23, A23. So it is very simple. So if you want to find A plus B, simply we can do. First of all, write down the two matrices. 2, 3, minus 1, 4, 0, 3, that is A plus B. 0, 1, 0, 2, 3, 6. Okay, A plus B. Now very simply we can do adding the two corresponding elements, that is 2 plus 0, 3 plus 1, minus 1 plus 0, 4 plus 2, 0 plus 3, and 3 plus 6. Okay, now we derive the answer. 2 plus 0 is equals to 2, 3 plus 1, 4, minus 1 plus 0, minus 1, 4 plus 2, 6, 0 plus 3, 3, 3 plus 6, 9. Okay, so A plus B is equals to 2, 4, minus 1, 6, 3, 9. Okay, I hope you all understand what is addition and how to do addition, and when we can do add two matrices. Okay, two matrices can be added only if both are of same order, that is both are called as equivalent matrix. We can add only two equivalent matrix. Okay, and the addition is very simple, as we know, very simple addition. Okay, just the factor is here we have in a other shape. Clear? Just simply adding the corresponding elements. Okay, clear students? Please go through it carefully. Just have a look and note it down. Okay students, clear? Clear? So we cannot add two matrices with different order. Yes or no? Because here you can see, for adding two matrices we must have a corresponding element. If we don't have a corresponding element, we cannot go on adding. Clear? So opposing this condition, one example, if we want to add two matrices with two order, okay, that is not possible at all. Like see, if A equals to 2, 3, 4, 5, 6, 7, this is a matrix of 2 into 3, and we have B equals to 2, 3, 6, 4, 5, 9. Okay, this is a matrix of 3 into 2, 3 row, 2 column. Okay, so these two matrices cannot be added because it is not satisfy the condition that the both are not equivalent matrix and or the both are not of same order. Okay, so we cannot find A plus B here. Okay, because the condition is not satisfied. Clear? Okay, so another thing is that in addition, okay, see students, there are some properties of matrix addition. Clear? There are some properties. So after those, please write down the properties of addition of matrices. Okay, if you go through the addition, there are some properties. Clear? That should be followed. Okay, properties, as we know, the properties are used when we require it. Clear? Whenever we are in a complex situation, we can use the property to derive a solution. Clear? So addition theorem, okay, is also some properties that can be used to derive a solution when we have any confusion or when we have any complex situation. Clear? So what are those properties? We have four properties. That is number one, that is associative law. Associative law. What is associative law? Associative law means adding A plus B or B plus A. Associative, changing the or interchanging the place of two matrices. Okay, if A is given, B is given. If the first place is A and second place B, if we add both, then the answer is equal to B plus A. A plus B is equal to B plus A. That is called associative law. Associative law, that if the places are interchanged between two matrices, then the result has no impact. Okay, we derive the same result. Okay, that is denoted as associative law. Clear? Then second we have commutative law. Commutative law. Second is commutative law. Okay, what is commutative law? If we are going to add three matrices, A, that is A plus B. First of all, because at a time we can add two matrices, so if we do first A plus B plus then the third matrix C. Clear? A plus B, after adding A plus B, the product is again added with C. So A plus B plus C. Clear? So here if the place change, there is not a matter. What it mean? If we do A is separated plus or A is added with the product, or A is added with the addition of B plus C. B plus C. Clear? See, if we combine one with another or other with another, there is no difference. There is no significant difference in the result, in the answer. Okay, first of all, see, A is added with B and the result is added with C. What we derive is equal to A added with the addition of B plus C. There is no significant difference. Okay, students? Clear? Then another property is that the existence of inverse, or we can say the inverse law. What is inverse law? What is inverse law? Inverse law. What is inverse law? Inverse law say that if we add two matrices, that is A plus B, and we derive the answer is 0. Clear? When we add A with B, we derive the answer 0. Okay? Then we can say according to inverse law, A taken to the other side, that is A. Clear? With 0. So then we have A is equals to B goes to that position, that side, then A is equals to minus B. That is inverse law. Clear? If the addition of two matrices is 0, then the one matrix is equal to the inverse of the other matrix. Okay? Then A is equal to minus B. Or if we take B, then A again move to that other side, then minus A. Okay? That is inverse law. Okay? Clear, students? And then finally, if we add a positive or a matrix, clear, with a null matrix, if we add a simple matrix, value matrix with a null matrix, then the result is that same null positive matrix. Okay, as we know, 1 plus 0 is equals to 1. So same here, addition of a matrix A with null matrix, we arrive A plus null matrix 0, is equals to A. A plus 0 is equals to A. Okay? Clear, students? So here I want to request you all, please go through the properties. Means make your own example, do exercise it, that whether the properties are correct or not. Okay? Definitely those are correct, but it is better to realize it by yourself. Clear? So this is not a difficult situation or difficult condition. Okay? That I think you must able to do it with yourself, and I am not required to do here the example that I used to take A, B, then B, A, that we derive the same result, A, B, C, okay, and A equals to minus B, B equals to minus A, that we definitely derive. So that's why I request you all, please take your own example and do prove this property by yourself. Because if you do it by yourself, then only your concept can be clear. Okay, and see, this is not a difficult task, very simple. Okay, that is a task for you. Please do take your own example to prove those properties. Okay, clear? Okay, students? So please note it down. Then we go for the another operation, that is subtraction. Subtraction is not different from addition. As like addition, subtraction is also as like as addition. The condition is also same. Okay, that is the simple algebra that we do. Subtraction means subtracting one matrix from other, and there is the same condition for addition and subtraction, that is we can add, as like we can add two matrix if both are of same order. Same, we can two matrix can be subtracted if both are of same order. Okay, and the result of the subtraction can be derived by subtracting the corresponding elements. Okay, please complete it, then we can go through the subtraction. Okay, students? Then is the time for the second operation, that is subtraction. Subtraction of matrices. Okay, so subtraction means simple, that the result that we derive by subtracting one matrix from other matrix. Okay, subtraction means differentiating one matrix from other matrix. Okay, differentiating one matrix from other matrix. Clear? So to do so, we must follow a condition that two matrices can be subtracted only when both are of same order. That is, both must be satisfied to be equivalent matrix. Okay, if both are equivalent matrix, then only we can go for subtracting the true matrix. Okay, clear students? If you want to subtract two matrix, then both must be of same order. As like we do examine in the addition, subtraction is also like that. If you want to subtract, then there must be of same order. Okay, for example, if we take let m, I am taking another name of the matrix because you might think why sir only take a plus a b. Okay, so that is not a matter. We can take any English alphabet, subject to it must be a capital letter. Okay, let m is a matrix and is given as 0 minus 2 3, 0 minus 2 3, 4 1 minus 5 and 3 minus 4 6. This is a matrix of what order? This is a simply a square matrix of order 3 into 3. Okay, clear students? So may I ask here a question that how, or if somebody asks how many elements are there in this matrix? How many elements? They all are 1 1 1 column elements. How we know the elements? You might remind that I described in the previous class that how to find. Clear? Need not to go through counting all the matrix one by one, 1 2 3 4 5. Not required. We simply do what? 3 into 3 is equals to 9. So here we have 9 elements. Okay students, please do consider and memorize the previous concept. Okay, so here that is a one matrix and other is given and n is equals to 1 2 1 2 minus 3 2 0 minus 1 and minus 2 3 minus 4. Okay, we can take any example. Okay, that is no restrictions at all. So this is also another 3 into 2 matrix. So here we can do subtract m from n. Clear? So if we ask to find m minus n, simply what we do? It's very simple. First of all, write down the both matrix 0 minus 2 3 4 1 minus 5 3 minus 4 6 minus 1 2 minus 3 2 0 minus 1 and minus 2 3 minus 4. Here is the two matrix we need to subtract. So here m minus n equals to 0 minus 1 corresponding element, 0 minus 1, then minus 2 minus 2, 3 minus 3, sorry 3 minus minus 3, then 4 minus 2, 1 minus 0, minus 5 minus minus 1, 3 minus minus 2. See students, here plus and minus is very important. Okay, because if we make any mistake in plus or minus, our result may differentiate. Okay, कुछ अलग आ जाएगा. Okay, so that's why do remind here the plus or minus rule. Okay, then minus 4 minus 3 6 minus 4. Okay, so what we derive? Here we derive 0 minus 1 is equals to minus 1, minus 2, minus 2. Okay, minus 2, minus 2. What we get? Minus 4. 3 minus 3. Here minus into minus, minus plus. So 3 plus 3, 6. 4 minus 2 equal to 2. 1 minus 0, 1. Minus 5, here minus plus. Okay, so minus 5 plus 1, that is minus 4. 3 minus plus. 3 plus 2, 5. Minus 4 minus 3, minus 7. 6 minus 4, minus plus. 6 plus 4, 10. That is the answer. That m minus n is equals to minus 1, minus 4, 6, 2, 1, minus 4, 5, minus 7, 10. Okay? Please note this down. Okay? So we have no property in subtraction. That is a very simple trick. We do not have any property in subtraction. Okay? Now we can go to next operation, that is multiplication. I hope you all understand how to do addition, subtraction, and now you are going to learn how to multiple two matrices. Okay, students, see, the third operation is multiplication of matrices. Okay, multiplication. Same, we can multiple two or more matrix at a time to derive at a solution. Okay, so what is multiplication? Multiplication is the product of two matrices. The product of two matrices, say A and B. If multiplied, then the result is denoted as A into B. Okay, A into B, multiple A multiplied by B, that is multiplication. Okay, so for multiplication we have a condition. For multiplication also we have a condition. If we go through the condition, then only we can make a subtraction. Sorry, we can go a multiplication. Okay, so see, what is that condition? Okay, two matrices can be multiplied. Two matrices can be multiplied. Two matrices can be multiplied if the number of column in the first matrix, if the number of column in the first matrix is equal to the numbers of row in second matrix. The number of column in first matrix must be equal to the number of rows in the second matrix. The number of column in the first matrix must be equal to the number of row in the second matrix. If this condition is satisfied, then only we can go for multiplication. Okay? Clear, students? So, for example, if I take P is given 0, 1, 2, 3, 4, 5. Okay? So here we have 2 row and 3 column. We have 2 row and 3 column. That is the first matrix is given, and Q is given as A, B, C, D, E, F. Okay, that is another matrix where we have 3 rows. We have 3 rows and 2 columns. We have 3 rows and 2 columns. There is only one condition, okay, that the number of column in the first matrix, this is the first matrix, here P is the first matrix, Q is the second matrix. First, according to its order, first is given P, second given Q, so P is called first matrix, Q is called second matrix. Okay, so first matrix, the number of column in the first matrix. So what is the number of column here? We have 2 row and 3 column. We have 3 column, C1, C2, C3. We have 3 column. It must be equal to the number of rows in the other or the second matrix. So see, here we have 3 rows, row 1, row 2 and row 3. So here the condition is satisfied, yes or no? Because we are going to multiple 2 matrix in which the number of column in the first matrix is equal to the number of row in the second matrix. So the condition is satisfied. So now we can find P into Q. We can find P into Q. P multiplied by Q. Okay? If that condition is not satisfied, and do forget about, only consider the number of column in first and row in second, and no matter, see, as we hear the number of row and here the number of column is equal, but if does not equal, then also we can go for multiplication, because there is only one condition, the column must be equal to the row, column equal to row, column equal to row, first column, second row. If both are equal, then we can go for multiplication. Okay? Clear, students? Note it down, please. Put a simple pressure on your mind. Okay? And try to understand what is the concept and what is the condition. Okay? First, if you understand the condition, then it is not a difficult task. Okay? You can easily multiple 2 matrices. Okay, students? So, now, clear? So now we are going to find the multiplication. How to find the multiplication? See, what is the procedure of multiplying 2 matrices? That is important. So I think before going to multiplying this, we should know the properties of multiplication. So after getting the property, then we find the product of two matrices. Okay, because I want you first clear the theoretical concept, then we go to the practical, because in the multiplication, that is a you need to put some pressure on your mind. Okay, because this is a little bit, okay, not to, I cannot say it is difficult, but you need to keep on concentrate the each and every process. Okay, if you forget, or if you are not concentrating, if you lost your concentration at any point, then it is very difficult to find the product of two matrices. Okay, so that's why first of all I am going to describe here the property, then we go for multiplying the two matrices. Okay, so what are the properties? The properties, that is, number one, if A and B are two matrices, then A into B may not be equal to B into A. If A and B are two matrices, if A and B are two matrices, then A into B may not, we cannot say is not. Clear? There is no condition that definitely both are not equal. We cannot say may be equal or may not be equal. Okay, so if A and B are two matrices, then A into B may not be equal to B into A. According to our associative law, that we do A plus B equal to B plus A, but here A into B is not equal to B into A. Okay, may not be equal. Okay, it may be equal. We may A into B may be equal to B into A. Okay, here he is not saying that that is not equal. Here the word is used may. May means that is a condition, may not be equal. We cannot say both must be equal. We say the both may not be equal. Okay, clear? That is the first property. Then second property we have, if A, B, C are three matrices, then the commutative law is followed, as in the addition theorem. If A, B and C are three matrices, then if we do A into B and the product is multiple with C is equal to A multiplied with B into C. Okay, so as per the addition theorem, the commutative law is followed over here. Okay, clear? Then third we say distributive law. Okay, what is distributive law? Distributive law means if we do A is multiplied with B plus C, A is multiplied with B plus C. So what it mean? It means A is individually distribute. We need to distribute A with B and A with C. So that is equal to A into B plus A into C. A into B plus A into C. Okay. If A is multiplied, combinedly multiplied with the addition of B plus C, then that is equal to A multiplied with B plus A multiplied with C. Okay. Clear, students? Then we have another property, that is according to transpose. That is, if first of all we do A multiplied with B, A multiplied with B, and then we transpose it. That is the symbol dash or T. As I say, we can say dash or T. So transpose of A into B is equals to the transpose of A into the transpose of B. Okay, the multiple of A into B is equal to the transpose of A and transpose of B. Okay students, clear? Then the product of two non-zero in which the elements are not zero matrix means null matrix. Okay, the product of two non-zero matrices. Okay, clear? Non-zero means the matrix in which we have positive integers more than 0. Okay, or positive, or we have negative but except 0. Clear? That is called non-zero matrix. So here 0 matrix means null matrix. Okay, 0 matrix means null matrix. Clear? So the opposite of null matrix that we have other matrix other than non matrix. Clear? That in which we have some value. Okay, so the product of two non-zero matrix may be a zero matrix. May be a zero matrix. Clear? It is possible, because if I take, okay, that we discuss in later, because now we have not going through the how to multiple. Okay, but remind it, the product of two non-zero matrix may be a zero matrix. Okay, we may derive a zero matrix, because as we know, if we multiple 1 with 0, what we derive? We derive 0. So that is the formula. Okay, that is the property. Clear? That if we multiple 2 non-zero, okay, or 1 0 with 1 non-zero, it may be a zero matrix. Okay, clear students? I hope all you are getting my point, all you understand what is addition, subtraction and multiplication. And now please note it down first, then we go to the next important section, that is to find the product of two matrix. That is the most important part in the operation, because addition is not difficult, subtraction is not difficult, both are very simple, but multiplication is not as like as addition and subtraction. It is little different but easy. If you concentrate, then it is very simple and very easy. Okay students? So see, now I am going to make a multiplication. Okay, see, we have two matrix, that is P is equals to, we have P is equals to 2 3 4 1 2 3. This is a matrix with order 2 into 3, 2 row 3 column, and we have Q is equals to, so here we must have a matrix with 3 rows. Okay, so 3 row, so we have 0 2 3 1 5 4. Okay, students, so here we have a matrix with 3 rows and 2 columns. 3 rows and 2 columns. Okay, so here the condition is satisfied, because the number of column in the first matrix is equal to the number of rows in the second matrix. Okay students, sorry, I forget to detect you one more thing, that in the multiplication, when we are going for multiplication, that we say first and second matrix. The first matrix, so here P, which is known as prefactor, okay, and the second matrix, here Q, is known as post factor. Okay, there is two factor, prefactor, post factor. So prefactor we consider column, and in the post factor we consider row. That both must be equal. Okay, the column in the prefactor, because it might be a multiple choice question. Okay, the column in the prefactor must be equal to the rows in the post factor to go for multiplication. Okay, so now we are going to multiple this. Okay, so see students, how we multiple these two matrices. Okay, see, the multiplication is going through like they say. In this trend, first the element of first matrix going through this movement from left to right, and those are connected or multiplied with the second matrix in horizontal movement. Okay, vertical to horizontal. Okay, so what it mean? See here, first of all, that is row 1, row 2, okay, row 1, row 2, here column 1, column 2, row 1, row 2, column 1, column 2. Okay, so the condition is column must be equal to the row, column must be equal to the row. So how we multiple, how we make the multiple? See, row 1, row 2, column 1, column 2. Now we need to multiple the row 1 of first matrix with the column 1 of second matrix. It is like 2 multiplied with 2 multiplied with its corresponding, who is corresponding? 0. 2 into 0. 2 into 0. Clear? 2 into 0. Plus, then 3. See the movement. See here, 1, 2, 3. 1, 2, 3. Okay, so here 1 to 1. Clear? Now second to second, which means 3 into here 2 plus, clear? Then 3 to 3. Okay, so see 1, 2, 3 in the horizontal, 1, 2, 3 in the vertical. Okay, row 2, column, 2 into 0, 2 into 0, plus 3 into 2, plus 4 into 3, 4 into 3. Okay, clear? Now, the time for this row 2, okay, the time for row 2. Same, row 2. Both are multiple with the column 1 and column 2. Both the row multiple with both the columns. Okay. So now 1 into 0, 1 into 0 plus 2 into 2, 2 into 2 plus 3 into 3. Okay, so 2 rows are derived. We have 2 rows. Okay, we have 2 rows. Then 2 rows only, this is only the first element, the second element. Okay, now students, the second, see again the row 1, row 2 is multiplied with the column 2, the elements of column 2. How? 2 into, now here 1, 2 into 1 plus 3 into 5 plus 4 into 4, 4 into 4. Okay, now 1 into 1 plus 2 into 5 plus 3 into 4. Clear, students? Got my point? Now it is very simple. We just make the other thing, that is 2 into 0 equal to 0 plus 3 2 is 6 plus 4 3 12. Then 1 into 0 equal to 0 plus 2 2 is 4 plus 3 3 9. Now 2 1 2 plus 3 5 15 plus 4 4 16. 1 into 1 1 plus 2 5 10 plus 3 4 12. Okay, now 0 plus 6 plus 12, 12 plus 6, here 18, 9 plus 4 plus 0, 13, 15 plus 16, 31 plus 2, 33, 10 plus 12, 22 plus 1, 23. That is the answer. Okay, please go through this. Okay, students, I hope you all understand how to multiple two matrix. Okay, so for your convenience, here I am taking another example. Okay, and the example of, this is the example of 2 into 3 and 3 into 3, 3 into 2 matrix. Now I want to do a sum of 3 into 3 matrix. Okay, okay, so we have A is equals to 1 2 3 2 1 5 3 2 7 and B is equals to 1 minus 2 3 4 minus 2 minus 7 2 4 5. Okay, so this is the matrix of 3 into 3 and this is also 3 into 3. So number of number of column 1 2 3, number of row 1 2 3, both are equal. Now we are going, we can do multiplication of these two matrix. Okay, so please consider it. Then I am going to make the solution of this problem. Okay, students, so see, here we are going to solve this. Okay, we are going to do A into B. Okay, so how can we go? See, as I do there, we need to follow this and this. Okay, that is the strategy. First prefactor, okay, is going like horizontal and post factor vertical. Okay, we consider the elements like that. See, 1 into 1 plus 2 into 4. See, row first we consider row 1, row 2, row 3, column 1, column 2 and column 3. First we consider row 1 to column 1, row 2 to column 1, row 3 to column 1. Then row 1 to means row is multiplied with column with each and every individual elements. Okay, first we go with row. So row 1 to column 1. 1 1 2 4 3 2 1 1 2 4 3 2. Okay, complete. Then row 2 column 1 2 1. See students, here you can mark here only these factors will be same, and only we required to put this value at the first point. Okay, 2 into 1 plus 1 into 4 plus 5 into 2. Then 3 1 2 4 7 2. 3 1 2 4 7 2. Okay, complete. Now next, now row 1, row 2, row 3 is multiplied with second column. Okay, like 1 into minus 2, 2 into minus 2, 3 into 4. Okay, 1 into minus 2 plus 2 into minus 2 plus 3 into 4. Okay, then we continue with the other numbers. 2 into minus 2, 1 into minus 2 plus 5 into 4. Clear? Now 3 into minus 2 plus 2 into minus 2 plus 7 into 4. Okay, I hope all you see, it's a very simple trick. 1 4 2. See here, 1 4 2 1 4 2 1 4 2 means the values of column 1 is individually multiplied with the values in row 1, row 2 and row 3. Okay, so see 1 2 3 2 1 5 3 2 7 only. So in the second position again 1 2 3 2 1 5 3 2 7 is multiplied with the value of column 2, that is minus 2 4 minus 2 4 minus 2 4 minus 2 4. Okay, same with the third, that is 1 into 3 plus 2 into minus 7 plus 3 into 5. Then we continue 2 into 3 plus 1 into minus 7 plus 5 into 5. Then 3 into 3 plus 2 into minus 7 plus 7 into 5. Okay? Okay students, now we are just going to solve these values. That 1 into 1, 1 plus 8 plus 3 to 6. 2 1 2 plus 4 plus 5 to 10. 3 1 3 plus 2 4 is 8 plus 7 to 14. Now 1 into minus 2 is equals to minus 2 plus 2 to the 4, but minus 4, because 2 into minus 2 minus 4. So here plus is converted into minus 4 plus 4 3 is 12. Then 2 into minus 2 minus 4, 1 into minus 2 minus 2. So minus 2 plus minus minus plus 5 4 20. Then 3 into minus 2 minus 6 plus 2 into minus 2 minus 4. So minus plus minus minus 4 plus 7 4 28. Then 1 into 3 3 plus 2 into minus 7 minus 14 minus plus minus 14 plus 3 into 5 15. 2 into 3 6 plus 7 into minus 7 into 1, minus 7, so minus plus minus 7 plus 5 5 25. Then 3 3 9 plus minus minus 7 2 14 plus 7 5 35. Now the next step, 6 8 plus 1 plus 6 9 15. Here we get 15 plus 16 plus 14 22 25. 15 16 25. Okay, then see here, minus 2 minus 4 minus 6 plus 12, minus 6 plus 12, that we get plus 6, minus 4 minus 2 minus 6 plus 20 plus 14, minus 6 minus 4 minus 10 is minus 28, so plus 18. Now see, 14 plus 15 29, 29 minus, sorry, 3 minus 14, 3 minus 14. Okay, 3 minus 14, 3 minus 14 is equals to 11, 11 plus 15 26. Then 6 minus 7. Okay, 6 minus 7, 6 minus 7 is minus 1, minus 1 plus 25 is equals to 24. 9 minus 14, 9 minus 14 is 5. Okay, minus 5, a plus 30 is equals to 30. So that is the value that we derive from multiplying A with B. Okay students, hope you all get the trick that how to make multiplication. Okay, please note it down. Then we left only one simple concept of multiplication. Okay, this is called multiplication of two matrices. Multiplication of two matrices. And we have a small concept relating to multiplication, that is called scalar multiplication. Okay, in which we multiply a given matrix with a constant single number. Okay, a simple number, any number. Okay, positive or negative integer. Clear? Which we called as a constant or scalar. When we multiply the constant or scalar with the given matrix, that is known as scalar multiplication. Okay, clear students? So see, please practice it, as more and more problem you can do, then only the multiplication, the trick of multiplication can be clear. Okay, so I suggest you do more and more practical problems by taking your own example, because here we know the condition. According to condition, you need to develop a matrix and can go through the multiplication. Okay, so now students, only one, that is scalar multiplication. Scalar multiplication. Okay, so what is scalar multiplication? Scalar, what is scalar? Scalar multiplication means a simple number, or we say constant number, constant, or that is known as scalar, is multiplied with a given matrix. The outcome or the result is called as, clear, or sorry, not the result, the process, clear, the process is known as scalar multiplication. Okay, there is no condition, there is no property for scalar multiplication. Is very simple. Okay, for example, if we have a matrix that is 1 2 3 4 5 6, okay, this is a matrix. Okay, and if we say to find 5a 5, so here see students, here 5 is a constant number, that we say a simple number or constant or scalar. When it is multiplied with 5, what we derive? 5a means simply multiple 5 with each and every elements of the given matrix. So 5a means 5 into 1 2 3 4 5 6. It means 5 into 1, 5 into 2, 5 into 3, 5 into 4, 5 into 5, 5 into 6. Means 5 is multiplied with each and every element. That we get 5 ones are 5, 5 2 10, 5 3 15, 5 4 20, 5 5 25, 5 6 30. Okay. So if a equals to this, 5a equals to 5 10 15 20 25 20 30. Clear? So this is called scalar multiplication. Scalar means a constant number. If a constant number is provided or given to multiple with a given matrix, the procedure is called scalar multiplication. Clear? In which we simply multiple the scalar, the constant number, with each and every element directly corresponding. Clear? Okay students, so here is all about the algebra or the various operations in matrix, that is addition, subtraction and multiplication, and we have division, which is not with a very simple division, which is not so applicable. Okay, only applicable in some one condition that we discuss in later class. Okay, so I hope you all getting my lesson, that is algebra or operations in matrix. Okay, if you have any doubt regarding any procedure that you may not or you might misunderstand, or you lose your concentration because of which you might feel difficult to solve these problems, then please do comment me on the comment section, then I will definitely clarify your doubt. Okay, so thank you students for your patience, for your kind presence, and I hope I am giving you good service. And in the next class we are going to discuss the other things in matrix, because matrix is a huge chapter. There are number of things are there. Okay, other things are also there. We have not yet go through the how to find the matrix. Okay, how to solve the equation, linear equation, that is a thing. So for that purpose we need to go through these small steps, then only we can go to the final step, that is to solve the linear equation by using matrix. Okay, so thank you students. In the next class we go through the other topics in matrix. Okay, thank you.